Hello and good evening, Cisco Networking Academy instructors taking the Python Programming Initiative course. In this short video tutorial, we're going to revisit augmented assignment statements, or what the course is referring to as shortcut operators. We're going to take a look at operator associativity, or operator precedence, and then we're going to talk a little bit about PEMDAS and how it might not be literally interpreted all the time, and specifically when we're doing augmented assignment statements. Now, remember that PEMDAS stands for parentheses, exponentiation, multiplication, division, addition, and subtraction. And in most cases, we're going to follow that order literally. However, you'll notice that I've placed some brackets around M and D for multiplication and division, and I've placed some brackets around A and S for addition and subtraction. And that's because multiplication and division share the same precedence, and addition and subtraction share the same precedence. And we're going to walk through some examples to see where PEMDAS might not be followed, because when two operators share the same precedence, they're said to have operator associativity. Again, and another way of saying that is, if you have operators with the same precedence, operator associativity is what's going to be used to determine which of those operators is evaluated first. And again, this is sort of counterintuitive because we've talked about PEMDAS in the context that parentheses come first, exponentiation second, multiplication third, division fourth, addition fifth, and subtraction sixth. But as we're about to see, that's not always the case, and again, in the context of dealing with augmented assignment statements. So let's jump out to the interactive interpreter, and let's take a look at the example question that we saw in the course material. And what we had was A was set to a value of 6, B was set to a value of 3. And then many of you, when seeing the equation A, and this is again our augmented assignment statement, which is / equal 2 times B. Now, many of you ran this command and you got the correct answer. However, there were multiple people that broke this command back out into its extended form, which would be A gets the value of A divided by 2 times B. So if I hit enter, what do you think the answer is going to be when we are not using augmented assignment expressions? And again, the augmented assignment expression is simply combining the assignment operator with our mathematical operator, the / for floating point division. Well, if we follow PEMDAS here, what we would naturally do is say, okay, M comes before D. In other words, multiplication comes before division. So by putting parentheses around 2 times B, I'm just drawing your attention to the fact that multiplication, based on PEMDAS, should be done first. Well, this would yield 2 times 3 and give us a product of 6. And then, if A is set to 6, which it is, we would have 6 divided by 6. And that would give us a quotient of 1.0. So we would end up with 1.0. And that was actually the answer to the question in the online course. However, when it's broken out and written like this, we end up with a very different answer. So let me go ahead and pull back those characters that were just written. And let's take a look at what A actually equals. So right now, A is referencing a value of 9.0. And you might be asking yourself, well, wait a second, how is that possible? Because PEMDAS says that multiplication is for division. And this is where operator associativity comes into play. And it's just simply a fancy way of saying that if we have an expression where 2 or more operators of the same precedence are in that expression, then operator associativity is going to dictate which of these operators is evaluated first. Now, with the exception of exponentiation, all of the operators that we're going to be working with have left to right operator associativity. In other words, when we have an expression with two or more operators of the same precedence, operator associativity says with division and multiplication and addition and subtraction, we're going to evaluate the left-hand term first. And that's what happened here. So when A had a value of 6 and we divided by 2, we would have received 3.0. And then we multiplied that by 3, and that is how we arrived at our answer of 9. And it's all due to operator associativity and the fact that the associativity, the operator associativity for multiplication and division, is to go from left to right when two or more of the operators with the same precedence are in that expression. And that's why it equaled 9. So let's reset things here, and then let's break down why the answer was 1.0 in the example. So, and let's actually do this. Like, reset things here. We'll say A gets the value of 6, B gets the value of 3. So now when I say A / and then the assignment operator, 2 times B, and I hit enter, and then I enter A, this is where a lot of the confusion came into play. Was this expression here is equivalent to the augmented assignment expression again, and that's the augmented assignment operator right there. And these are equivalent in basic uses that we typically use, which is to maybe increment some variable by 1 or 2 or some number, or to decrement some variable's value by 1 or 2 or some other value. And we don't have any issues there. And it's actually highly convenient to be able to say A gets the value of A plus 1. And using that augmented assignment expression saves us some typing, and it's very nice and consolidated. And the same thing is true if I wanted to decrement the value of B. I could say B gets the value of B minus 1 using the augmented expression. And again, remember, augmented assignment expressions are being referred to in the course as shortcuts because we're not writing out the entire expression, which would be A gets the value of A plus 1, or B gets the value of B minus 1. These are not augmented assignment expressions. Again, this is sort of longhand. Here are the augmented assignment expressions. Now, these typically work great, but as we've just seen, we can end up in a scenario where when we're thinking that PEMDAS is going to be in charge, it actually isn't in charge. And so we saw here where the division is going to be done first, and then the multiplication is going to come into play, where we end up with 9.0. And then we have the augmented assignment operator, which gives us 1.0. So let's go ahead and take a look at the augmented assignment operators. And give me 1 second here to clean this up. And let's take a look at the Python documentation to make sure that we're following this correctly. Now, augmented assignment expressions like x plus equal 1 can be rewritten in their longhand or native format as follows. And we're very familiar with this. X gets the value of x plus 1. Now, you'll notice it says to achieve a similar but not exactly equal effect. And here's where it's a little bit different. In the augmented version, x is only evaluated once. Also, when possible, it talks about performing the operation in place, and we've discussed that. And where is that place? Well, in place in memory. So instead of creating a new object, which would be located in a different place in memory, in most cases, it's going to be done in place. Assigning that to the target and the old object is modified, and that the old object's modified instead. So unlike normal assignments, where we would say something like x gets the value of x plus 1, augmented assignments are going to evaluate the left-hand side before evaluating the right-hand side. So for example, and here's an example that they give, where what's going to happen is Python is going to look up, in our case, and let's rewrite our augmented assignment expression over here, which was a / equal 2 times b. Keeping in mind that a had a value of 6 and b had a value of 3. So if Python is first going to look up a, it's going to look up and see that a has a value of 6. Then it's going to evaluate, in this example, f of x, it's going to evaluate this on the right-hand side. Remember, this is the expression over here, right? So 2 times b, well, 2 times b is going to give us 6. And then it performs the addition, right? Which is, there's our little mathematical operator. So now it's going to perform the division, and it's going to give us 1.0. And lastly, it writes the result back to our value or our variable a. And that is how a ends up being 1.0. And again, where we had the broken out equation with the division on the left of the multiplication, that is where operator associativity came into play. So let's take a look at an example that's using addition and subtraction, where we might see the same thing where PEMDAS doesn't actually hold up like we would literally interpret it to hold up. So if we come back over here to the interactive interpreter, and I was to do the following, and again, I will literally just type in, I'm not going to be assigning any values here. Let's just simply say 5 plus 12 divided by 2 times 4. So now you can see we've got this third mathematical operator here, the plus sign. However, remember, both division and multiplication have a higher precedence than addition. And it's here where we have multiplication and division. In other words, we have two operators in the same expression. So what is going to be used to determine, do we do the multiplication first or the division first? Now again, if we literally interpret PEMDAS, we would do this, because PEMDAS, you kind of always assume that the M comes before the D, and it does in the mnemonic. However, here it's operator associativity that is going to dictate the precedence of this operation. So if I was to hit enter right now, and we were following PEMDAS literally, we would see that 2 times 4 is 8. And then 12 divided by 8 is going to give us some crazy floating point number. And then we would add 5 to that. Now, that's if we followed PEMDAS literally. So let's go ahead and we're going to pull this expression back. And I'm going to put parentheses around 2 times 4 so that we can see the answer that we would get if, in fact, the multiplication was run first. We would end up with 6.5. Now, what if I don't put the parentheses there? What if we allow operator associativity to do its thing and to evaluate the division operation first, then the multiplication, and then finally the addition? And so what we should expect to get is 12 divided by 2 is 6, times 4 is 24, plus 5, and we're doing floating point division, should give me 29.0. And so again, this is one of those expressions where operator associativity will come into play because we have two operators of the same precedence. So now one final example here is, let's throw in an example with addition and subtraction where we have to look at operator associativity, where we have 9 times 3, and then we're going to take minus 4 plus 54. Now, odd number, but we want to make sure that we have something that's very conspicuous, that's going to be obvious when we see the answer as to which operation took place first. So, according to PEMDAS, you would take 4 plus 54, because again, and correction, so we will always do the multiplication first. I got a little bit ahead of myself there. So we will always do the multiplication first because that has a higher precedence than both subtraction and addition. So 9 times 3 would be 27. So then the question becomes, do I subtract 4 from 27 first, or do I add 4 and 54? What am I going to do? Well, let's go ahead and put parentheses around what we would think, according to PEMDAS, would be done first, and that would be the addition, because subtraction comes last. And when I hit enter, you can see we get the answer of negative 31 if we were following PEMDAS. However, let's remove the parentheses here, and let's allow for operator associativity to do its thing. And what's going to happen is the subtraction, because again, the operator associativity for all of the operators that we're working with, when there are multiple operators of the same precedence, will be evaluated left to right when 2 of those operators are here in the same expression, just like this. So now when I hit enter, we end up with 77 because we multiplied 9 times 3 and got 27. And then from 27, we subtracted 4. 27, or 4 taken away from 27 leaves us with 23, and then 23 plus 54 gives us 77. So let's go ahead and wrap this tutorial up by saying that PEMDAS is a good general rule of thumb to follow. However, keep in mind that when you write PEMDAS out, you should really be thinking about it as anything inside parentheses will be evaluated first, followed by exponentiation, and keep in mind that this is going to be evaluated right to left when we have operator associativity with exponentiation, as opposed to multiplication and division, which share actually the same operator precedence. And they have operator associativity. They're associated with each other because they have the same precedence. And then we have addition and subtraction, which are also associated with each other because they share the same precedence. And when we have multiple operators with the same precedence next to each other like this, we need to be aware that it will be the operator associativity, which is left to right as to how these will be evaluated, as opposed to following literally parentheses, exponentiation, then multiplication, then division, then addition, and then subtraction. And let's also keep in mind that we need to be aware and notice when we have augmented assignment expressions that we're using, again, typically, it's going to be something very simple where we're incrementing or decrementing. However, you might end up in scenarios where you're using augmented assignments and you don't end up with the result that you thought you were going to get. All right, that'll do it for this video tutorial. Thank you so much for watching. If you have any questions, please don't hesitate to ask. Have a great evening.